Next one today, pyramid. Big difference between a pyramid and the prisms we did yesterday. How many bases did the prisms have yesterday? Always two. Pyramid, one base. All right, let me talk to you about that base too. Okay, so pyramid's got one base, always regular. Always regular. Anybody want to remind me what regular means? 35 weeks into the school year now. If the base is regular, what do I know about it then? There it is. Here we go, 26. If the base is regular, what do I know about it then? A regular figure. Regular figure. Come on, Jack, 35 weeks in. If a polygon, a shape is regular, all sides are equal. All angles are equal. Everybody good? So if it's a four-sided figure, you can assume it's a what? It's a square. Okay? If it's a triangle, you can assume it's equilateral. All right? Everybody good? Tell me something about the non-base of a pyramid. Take away the base, the rest of the faces are what? Triangles, yes. And I'm even going to make it even more specific, congruent triangles. So congruent triangles as faces. All right, here's the big thing. There are two heights on a pyramid. I didn't stutter. Two heights on a pyramid. How many of you are familiar with the Mission Impossible series? A little bit? Okay, a little bit. All right, you know it's pretty action-packed. I want to now describe to you visually what the difference is between the altitude of a pyramid and the slant height of a pyramid, because I'm going to be referring to both, and you got to know where they are. All right? So here is the difference. I want you to pretend you're inside the pyramid right now. At the very top, where all the triangular faces meet. Everyone see that point where it meets? You're at the top, inside the pyramid, and you need to get down to the floor. All right? By the way, if you want to impress anybody today, the top of the pyramid is called the apex. Apex, if you want to impress anybody. So you're inside, you're hanging on to the apex for dear life, and you need to get to the bottom. All right? So you let out your rope. From the apex down, you let out your rope. Guys, that rope is your altitude. Everyone got it? Inside, from the apex straight down to the floor, that's your rope. So you're going to slide down on. That is the altitude. Everyone good there? All right. So there's my altitude. That'll get you down from the apex all the way down to the floor. That is your altitude. So where's your slant height? That's the height on the face, on the triangular face. Watch this now. Whoop! See that height I just drew in? That is the slant height. See the difference between the two? Because we're going to have to use both. Everyone good? You got the altitude, which is from the apex down, and then you have the slant height, which is actually on one of the faces. And I don't want you to do this. Just watch when I do it. When I connect those two, do you know what it forms inside the pyramid? A right triangle. And guess what we're going to do on that right triangle? Pythag, yeah. Because you're going to know two of the sides, but you got to find the other one. All right? So we're going to do a little Pythag on that in a couple minutes. But is everyone all right? The difference between the altitude and the slant height. We're all good there. All right, good. Here we go then. Lateral area. I don't want anything formula. Just describe to me what lateral area of a figure is from yesterday. What is the lateral area of a figure? Just describe to me in words what it is. 24. In words. Except the base. Except the base. What are all the figures except for the base? Triangles, right? So it's the area of all triangles, of all triangular faces. How many in this first figure here? How many triangular faces do I have? 4. So the lateral area is going to be 4 times, what's the area formula for a triangle? 1/2 base times height. That's how I'm going to find the lateral area of a pyramid. Take off the base and you got triangles left. All right, stay with me. 4 times 1/2. Can somebody give me the base length of one of the triangles? The base length of, take one of the triangles and give me the base length. 22? 12? Ooh, here we go. Now it gets a little nuts. The height. Hey, I'm not talking the altitude and the Mission Impossible height here. I'm talking about the height on one of those triangles, also known as, what do we just call it? Slant height. The slant height. I don't know it, but how can I find it? Pythagorean theorem. Okay? So when we talk about the height of one of the triangular faces, we're talking about the slant height. Ooh, ready? Well, you know it's 8 squared, right? Plus, you bet, hopefully we're not plugging in 12 squared. Anybody know how we're going to find this part here? It's going to be pretty easy. I'm just going to take half the base. Half the base length. So 6 squared equals my slant height squared, or in this case, c squared. What is the slant height in this case? How long is the slant height? 1. How long is the slant height, Maddie? 10. Good job. So I'll plug 10 in now. And what do you guys ended up getting here? 18 for the lateral area. 240 square feet. Yep. Yes. Yeah, that's fine. Yeah. I just don't want you guys to remember 80,000 formulas. See what I mean? Okay, I'd rather you just know, okay, I know lateral area, take off the base, there are triangles left, I'm going to do triangle formula, okay? Instead of remembering, well, if it's this kind of pyramid, I'm going to do this formula. If it's this type, this formula. Okay, it's too much for some people to remember, and me too. All right, what about surface area now? Describe to me yesterday. What was surface area from yesterday? Make this a little easier on us. 15, what was surface area yesterday? Okay, you said base is. Today, though, it's just base. So it's going to be your lateral area plus the base. Singular. All right, same diagram I just had for you guys, so we don't have to find the lateral area. We already know that's going to be, what did we find that? 240? All right, I'm going to turn it over to you. What are you going to add in now? What are you going to add in? Look at the base. How do you find the area of the base? 10. How do I find the area of that base? 12 by 12. So I'm going to add in the 12 by 12 base. I won't ask anybody this, but 340 84 square feet. Okay. Any questions there? All right. Just a couple more to make sure before we get to our big dog one. Okay, just lateral area. Just lateral area. Uh, 13. How many triangles are there for faces? 4. 1/2. Look at this, guys. Base and the height of one of those triangles. 29. Base and height, Billy. 10 and 13. You don't have, everyone see, no Pythag needed here. I gave you the slant height. We're good to go. It's when I give you the Mission Impossible height, you got to do a little work. So you guys start crunching those numbers. 260. How's that look? 260? Inch, thank you. Inches squared. Yeah, no, I'm good. What you got, bud? It's not going to be needed. When we get to volume, it'll be needed, though. Volume involves that height. But now, no. No need for it. Okay, 2. I don't know if this confuses everyone because I tipped it upside down. How many triangular faces do you have? 4. And what is the base length of one of them? 7. Now, this 7 that it's pointing to here, is that the slant height or is that my Mission Impossible height here, the altitude? That's my Mission Impossible height, so I can't plug 7 in again. I'm going to have to do Pythagorean theorem. So I'm going to have to say 7 squared plus, watch your mouth now. What's this piece right here? Half the base, 3.5 squared. And you're right, you're not going to get a pretty number here. When you finish that Pythag, you're not going to get a pretty number. You guys taking the square root of 61.25? Good. And we do have rounding directions. Nearest tenth. $12. What are you getting for the lateral area? Yep. Good job, everybody. You and your group or by yourself, number 3, surface area. Surface area now, surface area. I just want to see if, okay, I did give you that problem. Shoot. 6, what's across from this 60? 3 radical 3. So it's going to be 6 triangles times 1/2 times base of 6 times the height, 3 radical 3. That is what I'm going to add to that lateral area we just put up there. Okay, that's what I'm going to add to the lateral area. So I'm going to go ahead and crunch it right now. That is what you're going to add to the lateral area. Yes, go ahead, Mason. We're using the same directions from number 3, so we're nearest 10th. And when you get that number, let me know. Take your time, though. 2018, when you get that number. Nice job. 309.5 square meters. Whew, we are right there. All right, I'm done for the day. You're not. All right, you know how we end it. A figure and another figure. Let me first give you a little push. Name the two figures that this house makes up. What's on top? What's on top? Pyramid. You're going to add that to what's on the bottom. What did we call those yesterday? Rectangular prisms. Okay, so as you and your group do this, when you go to the pyramid, if we're finding the surface area, what can you not count? What's covered up? The base. So basically, think about this. What are you just going to do for the pyramid? Lateral area. For the prism, what's covered up? The top. So you can't count that. You got to count all the rest of the 5 faces, but that top one. All right? There are no rounding directions because none are needed. This should come out to be a whole number. If you think you personally or your whole group got it, call me over. If you're struggling, call me over. All right? Because that's where it's going to end here today. I'll just write it in for the people at home.